All right, so this is the sixth video in our series on factoring. And in this video, we're going to tackle factoring problems that involve multiple steps. So we're going to be using more than one of the rules that we've discussed in the previous videos. Now, honestly, most of these problems are really going to involve factoring out a GCF first and then applying one of the other rules afterwards. Let me give you some basic guidelines for this. The first couple of these are really important. Anytime you're factoring and you create a new factor, so you pull something out or you take a factor and you split it into two factors, you must check any new factor that you've created to see whether it can be factored further. Now, factoring in general, you're always going to want to look for a GCF first. So it's really important. Go ahead and check for a GCF first. If you forget to do this, then you basically are going to be making the problem a little bit harder on yourself than it needs to be. Plus, you're going to need to eventually factor that GCF out anyways, so always check for a GCF first. And then beyond the GCF, use the number of terms that you see in the factors to determine which method you should be using. If you see two terms and you know you're looking at possibly a difference of squares or a sum or difference of cubes, three terms, you're stuck with guess and check. Four terms, you're going to be using factoring by grouping. And then finally, always check at the end. If you think you're finished, go back, look at each of the factors that you've created, and ask yourself, can that factor be factored any further? We'll be examining just this one problem here together, and you can find several other examples, though, further down the playlist. So 2x to the fourth minus 54x. We should always check for a GCF first, and as I look at that, I do see x's in both terms. Also, I'm seeing a couple of even numbers. So let's go ahead and factor 2 out. And let's factor an x out because they both contain 2's and x's. So if I factor a 2 and an x out of 2x to the fourth, that'll just leave me with x to the third left over. Dividing that 2 out of the 54 is going to give me 27. And when I factor that x out, it'll just be the 27. Okay, so we've created really 3 new factors here. We brought a 2 out, we brought an x out, that's 2 factors, and then x cubed minus 27. We should check and see if any of these will factor further. Now, the 2 and the x are factored as far as they possibly can be, but the x cubed minus 27 can be factored one step further because that is a difference of cubes. So we're going to leave the 2 and the x out in front, but we need to factor this x cubed minus 27. Since it's a difference of cubes, we do know that it's going to be a binomial followed by a trinomial. Let's use the SOAP rule to figure out our signs. In the original problem, it was a minus, so we'll take the same, opposite, and always positive for our new signs. And let's figure out what building blocks we're going to use to fill in our terms here. To get x cubed, we were cubing an x, and to get 27, we were cubing a 3. So we're going to be using the x and the 3 in that first binomial. We'll be squaring both of those in the trinomial, and then for the middle term of the trinomial, we'll multiply those two things together, so x times 3. So let's go ahead and simplify this out a little bit. We've got 2x, and then we've got x minus 3. We've got x squared plus 3x plus 9. All right, so we have just created 2 new factors, x minus 3 and x squared plus 3x plus 9. We should check and see if we can factor those any further. Now, if you paid attention, when we were talking about difference of cubes earlier in a previous video, we said that if you started with something that did not have any GCF of any sort, then you would not be able to factor either of these factors any further. And since that's the case, I am confident that this is factored as far as it could possibly go, and that's going to be our final answer.